Hello everyone, my name is Saloni Vishwakarma. I am a student of International Institute of Professional Studies. Currently, I am pursuing MCA. Today, we are going to understand some topic of cloud computing. So, here we start. The topic name is hypervisors within the cloud computing. First of all, we have to know the introduction to hypervisors, understanding of hypervisors within cloud computing. Uh, we will discuss about the introduction to hypervisors, role of hypervisors in virtualizations, and importance of hypervisors in cloud environment. There are two types of hypervisors. Uh, Understanding the difference and use cases in cloud computing. Type 1 hypervisors. Mm, this type runs directly on physical hardware, providing high performance and efficiency, and it is ideal for enterprise environments where resource management is crucial. And example its example like VMware and Microsoft Hyper-V offer better security and isolation as it has direct access to hardware, and it's also require more systems resources but provides robust scalability. Second type is type 2 hypervisors, which is run on a host operating system, leading to slightly reduced performance, commonly used for personal or development environments. And here examples are Oracle VirtualBox and VMware workstations. Uh, Type 1 hypervisors have some features and benefits. Example include VMware and Microsoft Hyper-V, which operates directly on hardware without an underlying OS. The key feature of the Type 1 hypervisor is they offer directly hardware access, allowing for optimal resource utilization and scalability for large workloads and enhanced security measures. Type 2 hypervisors features and benefits are ease of use. Type 2 hypervisors are designed for user friendliness, allowing quick setup and management. Its flexibility, they actually it is flexible. They support a variety of operating systems, enabling diverse applications to run simultaneously. Third one is ease of installation. Installation is straightforward, requiring minimal technical expertise compared to Type 1 hypervisors. Compatibility with various operating systems, they can run on top of the existing operating systems, making them versatile for different environments. Here are some architect of hypervisors, understanding the key components and interaction in hypervisor system. First, hypervisor kernel, the core component of managing system resource and VN operations. Management console, which interface for administrators to manage and configure VMs. Virtual machine monitor, which is VMM, software layer that enables multiple VMs to share hardware resource. Physical hardware, that the actual server hardware that run the hypervisor and VMs. Virtual machines, there is virtual machine management, understanding the role of hypervisors in cloud computing. First one is critical function of hypervisors, which is managing virtual machines is essential for the operations of hypervisors, enabling efficient resource distribution. VM creation and resource allocation is also a management of virtual machine, which includes the setup of virtual machines and the, we can say, allocation of vital resource such as CPU and memory. Third one is VM lifecycle management, which covered the complete lifecycle of virtual machines from creation to deletion, ensuring effective management. Fourth one is efficient resource utilization, which in which hypervisors play a significant role in ensuring that resources are used efficiently, optimizing performance. These four are the virtual machine management in the cloud computing. There are also some topics in the cloud computing which are very important for us to know, that resource allocation and scheduling. Here we understand the how hypervisors manage cloud resource effectively. Hypervisors manage resource allocation efficiently. They allocate CPU, memory, storage, resource among VMs to ensure balanced performances. Discuss on resource allocation. If we discuss on resource allocation, a detailed examination of how CPU, memory, and storage are allocated to VMs to meet varying workload demands and etc. There are more scheduling algorithm overview, an overview of various scheduling algorithms employed to distribute workload evenly across resources. And there are one more scheduling which is avoiding resource contention. Next, we have to move on the next slide, which is security purpose in hypervisors. There are lots of security. Here we understanding security features, challenges, and mitigation strategies. First one is isolation between VMs. Isolation between VMs ensures that each virtual machine operates independently, minimizing the risk of cross VM attacks. Second one is access controls, which is implementing strict access permissions to limit who can interact with virtual machines, thereby reducing authorized access. There are also security patches, which is regularly updating hypervisors software to address vulnerabilities and enhance security features. It is also have unauthorized access. This is a key challenge where attackers gain access to virtual machines, often leading to data compromise. Data breaches is also a security in hypervisors, which incidents where sensitive information is exposed due to weakness in hypervisor security. Uh, Inadequate security measures is one of the security challenges hypervisors, which focus when hypervisors lack robust security protocols, making them vulnerable to attacks. Seventh one is regular security updates, which is a vital strategy to keep hypervisor secure by applying updates that fix known security vulnerabilities. Eighth one is use of firewalls, which is implementing firewalls to monitor and control incoming and outgoing network traffic to enhance VM security. There are the last one is encryption technique, which is utilizing encryption to protect the data stored in and transmitted between virtual machines, we can say. Move to the next slide, which is performance optimization techniques, enhancing efficiency in cloud computing with the hypervisors. First one is optimizing resource allocation, which is efficiently distribute available resource like CPU and memory to enhance overall system performance. Second one is, which is very most important, using hardware acceleration feature that leverage hardware capabilities such as GPU and FPGA to speed up processing tasks in virtualized environments. Third, we can say monitoring performance metrics. There are some matrices, like one of them is monitoring, which continuously track key performance indicators to identify bottlenecks and area for improvement. Like there are some use cases with the hypervisors in the context with cloud computing, where we understand hypervisor within cloud computing. The role of hypervisors are pivotal in managing virtual machines and their resources in cloud computing. Service models, cloud computing leverage hypervisors in as PaaS and SaaS environments to deliver flexibility and scalability. Then service model is again connected with the public cloud deployment, where hypervisors facilitate resource sharing among multiple tenants while maintaining isolation. And again, public cloud deployment is again connected with the private cloud deployment, which is in private clouds offer enhanced control and security catering to specify organizational needs. And the private cloud deployment last is in lastly connected with the hybrid cloud, which is utilize hypervisors to integrate public and private resource enabling. Now we can compare popular hypervisors, a detailed comparison of VMware, ESXi, Microsoft Hyperware, and KVM. VMware is it has high performance with optimized resource management. It has excellent scalability options for growing workloads. It is user-friendly interface suitable for beginners, and it is very higher licensing cost compared to other options. As compared to VMware, Microsoft Hyper-V has strong integration with Windows environments for performance. It has also good scalability, especially in the enterprise environments. It is very easier to manage for users familiar with Windows, and it is very cost effective, often bundled with Windows Server. KVM is very excellent performance with kernel level of virtualizations, like highly scalable. It is very scalable, suitable for cloud environments. It is also open source platform, and its cost is very low. There are some challenges and limitations of hypervisors, exploring the drawbacks and potential improvements in hypervisor technology. Performance overhead, hypervisor introduce latency and resource consumptions, affecting overall performance. Security vulnerabilities, in which hypervisor can be target for attacks, leading to potential data breaches and security risks. Like, and third one is complexity in management. There is little bit complexity in the management. Managing hypervisor requires significant expertise, often complications. Future trends in hypervisor technology, exploring advancements and integration shaping cloud computing, evolving hypervisor technology, integration with container technology, enhanced automation, improved security features, just like that. And last, there are some case study, hypervisor implementation, exploring the process and outcomes of hypervisor integration, which includes objective of the hypervisor implementation, which is a virtualized environment that optimizes resource usage and enhance scalability. Implementation process, which is a step-by-step execution of hypervisors, installation and configuration within the cloud infrastructure. Third one is challenges faced during implementation, which is technical and operational hurdles encouraged while deploying the hypervisor. There is also a more benefit released from the implementation, which performance improves, cost savings, and increased flexibility post implementation. And the fifth one is real world insight, which lessons learned and best practice derived from the actual hypervisor implementation experience. So here is the some summary and key takeaways. Hypervisors with a cloud computing. Importance of hypervisor in cloud computing. Hypervisor play a crucial role in managing virtual machines, enabling efficient resource allocation and isolation. There are two type of hypervisor: type 1 bare metal and type 2 hosted, each serving different needs in virtualization. Key features include virtualization, resource management, and support for multiple operating system. Common use cases include server consolidation, development and testing environments, and cloud service. So here we are going to stop the topic. So thank you so much for your time. Thank you.